Hello and welcome everybody. In this video, we will walk through a demo CloudPoint 2.0, especially an overview of the summary screen and the dashboard screen, configuration of clouds and arrays credentials, creation and deletion of snapshots, recovering from snapshots, usage of role-based access control in CloudPoint, creation of snapshot policies, schedules, retention, storage levels. When a user first logs into CloudPoint, we are presented with a summary screen, what we internally also call is coffee screen. In the summary screen, the user is presented with a quick view of what's going on in the environment. So on your left, the user gets a status of tasks running in the environment, followed by configured clouds and arrays such as AWS, Google Cloud Console. On the right, the user gets to see what is the level of protection of discovered assets. For example, if 100 disks were discovered in the platform and protection policies were applied to only 50 of those, then the environment has achieved a protection level of 50%. Next up, the dashboard. On top, we see a repeat of the information provided in the summary dashboard. Below that to your left is the environment console. In CloudPoint, we divide discovered assets into 4 categories: applications, hosts, file systems, and disks. Applications. These are the traditional applications such as Oracle and SQL servers, as well as cloud-native apps such as RDS and Aurora. Hosts, these are the same as a EC2 instance, as a VMware VM, a physical machine, any of those counts as a host. File systems, they're broadly divided obviously into 2 categories, Windows and Linux. In Linux, for example, we can track ext3, ext4, XFS, similar for Windows. Disks, these can be any volumes discovered, EBS volume, an Azure managed disk, any of those is an individual disk. To the right, we have the administration console, where the user can manage several configurations: clouds and arrays to manage credentials for different platforms. We'll see that in detail. Policies to manage snapshot policies in an automated fashion. Roles to define and manage role-based access control. Users to manage your users either through LDAP, that is the Active Directory integration, or local users managed by CloudPoint. Let's dive into clouds and arrays configuration. We support a number of clouds and arrays, anything from Amazon, Azure, and Google Cloud to VMware VMs, Nutanix Acropolis hypervisors, HP 3PAR, HDS, Hitachi G1000 series, and all of the others. Let's configure an AWS instance. For example, to configure AWS, we need the user to select regions to manage, then provide the access key and the secret key. When we go back to the dashboard, look at the job status log. That shows a new plugin configuration task is in progress. In the background, CloudPoint uses the credentials to discover all the EC2 instances, EBS volumes, and RDS databases as well. As the discovery happens, CloudPoint keeps updating the number of applications, hosts, and disks discovered. In the next step, let's create a snapshot of the host. Clicking on Manage under the host takes you to the asset management screen, where all the hosts are listed. Selecting an asset shows finer controls for the asset. As I select EC2 Test 1, I can see the platform is AWS. It's located in the US East 2 region. The asset is discovered and the credentials are valid so that CloudPoint can create snapshots. The details pane also shows us the policies attached. For this particular instance, we see that there's no existing snapshot. So let's create a new snapshot. From the details pane, click on Create Snapshot. In the pop-up, supply the name of the snapshot. This name tag is propagated down to the platform, in this case to AWS. This helps to identify the snapshot later from the AWS console as well. If we go back to the CloudPoint UI, we can now see a new snapshot under the asset EC2 Test 1 as well. We can now recover and restore using this snapshot. Since this is a host level snapshot, we are able to recover a full running instance. The snapshot can be restored to the original location and to your new location as well. CloudPoint intelligently discovers the possible target locations and shows them as options. Select the appropriate options, VPC here, and click Restore. Again, from the job log, we can see a new snapshot being created. The same is visible through the AWS console as one. As soon as a new EC2 instance is launched, CloudPoint auto discovers the new instance. In this case, the host count went up by 1 from 306 to 307. Next, let's look at roles in our backend CloudPoint. Roles allow the user to control which assets and workflows other users have control over. In CloudPoint, roles are comprised of three dimensions: users, permissions, and assets. You can choose a combination of users and permissions, users and assets, or all three. Roles can be modified later at a later point of time, as well to allow for organizational flexibility. Following from the principle of least privileges, there are no defaults defined by the system for a role or a new user. A new user must be designated under a role before they can perform any actions in CloudPoint. Let's define a role. To start, provide a name, description. Now, now select one or more users. From the Permissions tab, select one or more permission policies. And from the Asset tab, select one or more assets. Once the role is created, you can look at the Details tab to verify any changes. Now, when the user logs into CloudPoint, they will automatically be able to see the assets assigned to them, the permissions that they are given, and therefore act on the assets per the permissions provided. We obviously want backups to be automated to provide protection on an ongoing basis. Let's look into CloudPoint policies. On the policy management screen, click Create Policy. In the new policy screen, the user can choose the retention policy, the snapshot schedule, the storage level, if the snapshot should be application consistent, and also choose to enable replication. We recommend that customers enable app consistent snapshots by default if the option is available to you. This is most useful when protecting applications such as Oracle, SQL Server, and others. Now we define a policy. User needs to provide a name, descriptive text, choose a storage level between application, host, or disk. On the right-hand side, choose how many copies to be retained or how long each copy must be retained. Then set up a snapshot schedule. That's it. A new policy is now available that creates a snapshot every 2 minutes and retains the last 2 copies. We can now apply this host level policy to a discovered host. In a couple of minutes, a new snapshot task is kicked off. We see the snapshot reflected in AWS console as well. As the second snapshot kicks in, we see the same in the AWS console as well as the CloudPoint UI.